Hello, class. It's Saturday, December 18th, and I just wanted to announce that I've posted all your scores for week 3. And I also want to say something about the essay questions. Although most of you did fine on most of the essay questions, there were a couple of them that seemed to give most of you some trouble. So I want to talk about those. The first one is discussing, the issue of centripetal versus centrifugal force. Now, in physics, we have terms for these two types of forces. Centripetal force is an inward force, and it's a real force. It's something that's actually caused by something, whereas centrifugal force is called a fictitious force. It's only a perception of the person who's in an accelerated frame of reference. That also sounds kind of fancy, but the explanation, if you think about it a little bit, is quite simple. Okay, I'm going to use my limited talent here for drawing. I'm going to say, okay, you're in a car. You're here in a car. You're looking from above, and there you are in the driver's side, let's say. That's your head and your arms there. And the car, because you're steering the car wants to go around a bend. But while you're sitting in the seat, assuming there's really no friction or very little friction in the seat, the force is only downward. It's into the screen, which is a force of gravity. So as you're bending around the turn, your body wants to go in a straight line. Let me use a different color here. So your body wants to just go in a straight line like this. That's the way your body would go if there was no car surrounding you. You would be just going in a straight line. But because there's a car surrounding you, when you're at this point up here, okay, that's where you are. I'm going to try to give me a little bit of mercy here. I'm going to try to do something that may or may not work too well. Okay, I'm going to copy that image because I don't want to draw it again. Paste it. There it is. I'm going to drag it right where it would be if traveled in a straight line. Now the car, I'm going to try to copy the car. This may not work too well. The car is going to let me rotate it. No, I wish I could rotate the car, but the car would rotate and shift over to move along the turn. So you didn't change your horizontal position. You didn't change your position in the X direction. I'm going to draw an axis here. Okay. You moved in the Y direction, but you didn't move in the X direction, but the car did. And now, hopefully your arms are still on the steering wheel, but anyway, you would have shifted over to the right relative to the car. But what's really happening is the car itself is shifting to the left. You haven't changed it in the left or right direction. So now the car door is pushing on you. And since you can't pass through the car door, you are now being accelerated by a force from the car door that's inward. The car is pushing you inward. There's nothing pushing you outward because nothing accelerated you outward. You didn't accelerate outward from the path. You were traveling a straight line, and now the car has shifted its position relative to you. So it's a set inward force, not an outward force. This is centripetal force, okay? But the force is due to the side of the car or the car door, the passenger door pushing on you. Okay, there's nothing pushing you out, because otherwise you just go in a straight line. Okay, I hope that explains it. So, from then on, later on the car would be over here, and you're over here on the side of the car being pushed around this path. So now you're being forced along a circular path by the car. Like that. Okay. All right. And the other one was about the orbit. If a planet's orbiting an elliptical path, it asks all these questions. Where is the force of gravity the greatest? Well, we know force of gravity, the magnitude of the force of gravity is given by this expression. And it's biggest when r is the smallest. So the force of gravity will be the biggest at point A. Where is the greatest speed? Well, it speeds up, when it's out here, it's going slowly, and then it speeds up and then goes out slowly and speeds up near the sun. So its greatest speed will be when it's closest to the sun. Well, speed's just the magnitude of the velocity. So its greatest velocity will be near the sun, which is point A. Greatest momentum, well, usually letter P represents momentum. And the magnitude of it, the size of momentum, is the mass times the velocity. Well, if the velocity is the biggest at A, then the momentum will be its maximum value at A, assuming the mass doesn't change, which it normally wouldn't. So the momentum will be the greatest. The kinetic energy, well, the kinetic energy is the 1/2 times the mass times the velocity squared. If the velocity is biggest at A, then obviously kinetic energy must be the biggest value at A. Potential energy. Well, let's just skip for a second. Where's the greatest total energy? The greatest total energy, which is the sum of the kinetic plus the potential energy, that's constant because energy is conserved. So we just said that you have the maximum kinetic energy at A. That would be where you'd have the minimum potential energy. It stands to reason that as you move further out from the sun, the planet loses velocity. Its minimum velocity is at C, V minimum velocity. So the kinetic energy is a minimum there. But if kinetic energy plus potential energy is constant, then potential energy must be a maximum at A. Okay? Because here, kinetic energy is big, but potential energy is small. So you have a small potential energy and a big kinetic energy equaling the total energy, which is the same as at point C. But at point C, you have a small kinetic energy, and the only way to have total energy the same is for the potential energy to be big. So you have the maximum potential energy at point C. Then the angular momentum is constant. Angular momentum is usually represented by L. That's constant because there's no torque exerted by gravity. So angular momentum is the same everywhere. And then the acceleration. Well, acceleration is force. Force is mass times acceleration. If we set these equal, the force is provided by gravity. We set them equal, and the big M is the mass of the sun, the little m is the mass of the planet. Then this mass, you can divide that out, and you get acceleration is the gravitational constant times the mass of the sun divided by the distance squared. Well, again, to have a big acceleration, the distance must be small because the distance is in the denominator. So the maximum acceleration is at A. Okay, So I think I stepped through all those. There should be 9 answers. And you should see now how those answers come about. And there's the answer summarized. If I found any fault with your answer, I gave these answers to you in my explanation of how I graded your response. Okay. So there's all the answers to the different parts. And that's all for now. And I'll see you in class.